Adding a ticker to a simulation lets you track the state of each customer and station precisely as the simulation moves along. We've almost created a fully working version of the simulation that includes a ticker, but we still need to add a line or two of code that writes out the state of the simulation at each step. As before, I will use debug.print to write those results to the immediate window. To demonstrate this process, I will use the Chapter 03-04 sample workbook that you can find in the Chapter 3 folder of the exercise files collection. We don't need to make any changes to the Sim Setup worksheet, so I'll press Alt F11 to move to the Visual Basic Editor. And here in the ticker routine code module, I can scroll down to the place where I want to add the code. So I will scroll down, it's within the ticker, and you can see here that I have a comment called write out the state of the simulation. And here I will add a line of code that prints out the state of the simulation, or at least the parts we're interested in. So that is debug.print space and then double quote, I'm a customer, followed by a space and double quote, then an ampersand for concatenation. And this will be the customer's customer ID property value. So objc.custid, and then a double quote and a space, I'm in station, followed by a space, then double quote, ampersand, objc.station, ampersand, then a space, double quote, another space at time, then another space, ampersand L ticker. So what we've done is create code that will have a customer identify itself as being in a particular station at a particular time. In this chapter, you've added code to your simulation module to manage a business process by creating a timer. At each tick of the timer, your VBA code updates the status of each customer and station, moving customers among stations at the appropriate times. In this movie, you will run the simulation based on the code we've already created and take a look at the results that your code sends to the immediate window. My sample file is Chapter 0305, and you can find it in the Chapter 3 folder of your exercise files collection. We don't need to make any changes to the Sim Setup worksheet, so I'll press Alt F11 to move to the Visual Basic Editor. Our code is complete, but I do need to display the immediate window because that's where the results are going to be displayed. To open the immediate window, I'll press Ctrl G, and there it is. Now I'll go back and in the code module, click inside of the test update on tick method subroutine and run it by pressing F5. And you see at the bottom that we have a fair amount of information that has been printed out in the immediate window. I'll resize the immediate window so we can see more of what's been written there. So if we scroll all the way up to the top, I see I'm customer 1 and I'm in station 1 at time 1. Looks like customer 2 was created at the same time or entered the system at the same time, so it was idle until step 20. Then customer 2 was in station 1 at time 21. Customer 1 moved to station 2 at time 22. Then there are no further updates until 34, then time 40, and time 49. So it looks like our simulation ran correctly. The results that were written out to the immediate window using debug.print tells us that things are working well, and we can look for better or more effective ways to output the results of our simulation. In Chapter 3, we added a timer to our simulation so we could track the movements of 2 customers through 3 stations. In this chapter, we will extend that model to add customers throughout the simulation. We will use the Poisson distribution to generate random customer arrival times based on a known average gap between arrivals. We will also move the customer generation code inside of the timer because the timing will be driving when new customers arrive. We'll write the results of the simulation to a worksheet instead of using debug.print like we were before. And finally, we will run the simulation and fix a mistake that could lead to customers getting stuck in a particular station. When you model the amount of time between events, such as customers entering a store or cars arriving at a toll booth, you use the Poisson distribution from statistics to calculate those inter-arrival times. There is no easy way to calculate Poisson distribution results using a single Excel function But in this movie, I will show you a straightforward way to get the values you need using a series of worksheet formulas. My sample file is chapter 0402, and you can find it in the chapter 4 folder of your exercise files collection. Over on the left side of the sim setup worksheet, you'll see that we have the number of stations and then information about each of the stations. On the right, we have the Poisson data label here, and also below that we have the label for the mean. The Poisson distribution uses a single input value, which is the mean, to calculate its curve. You will also see the Poisson mean referred to as lambda. So let's say that we tend to get a customer every 20 ticks of the clock. That could be 5 seconds, that could be 3 seconds, whatever. So I'll click in cell J2 and type 20. Now I need to create formulas for the distribution results in cells M2 through M54. To select those cells, I will go to the name box at the top left corner of the worksheet and type M2 colon M54 and press enter. And you can see that those cells have been selected. Cell M2 is the active cell, so I'll start typing my formula there. So I'll do equal Poisson, P-O-I-S-S-O-N, .dist, followed by a left parentheses. L2 is the value of 0. So in other words, if a value of 0 comes up, then a comma, then J2, which I will make absolute because I don't want it changing. So I'll press F4. There we go. Then a comma and true for a cumulative probability distribution, and a right parentheses. What this formula does is calculate the probability that a particular value or less will occur. So we're looking at probability of 0, probability of 1, and all the way down to whatever value is in cell M54. With this formula in M2, I can enter it into the rest of the selected cells by pressing Control-Enter. And you see we get some very small values at the top, so we're almost never going to see a 0, a 1, a 2, and so on. But if we scroll down, we'll see that if the number is between 0.066 and 0.10486, then we will see the number 14 as our result. And it scrolls down. You can see that the average of 20 will occur more frequently than other values, and the likelihood of even larger values decreases as we go toward 1. Now that we have our lookup table in columns L and M, we can create a formula that will generate a random value using that lookup table. So I'll click in cell K2, type equal, and the formula is match, left parentheses, then rand with open and close parentheses, and a comma. The range is M2 to M54. Those are the cells in our lookup table, then a comma and 1. So we're looking for values that are less than the value in cells M2 to M54. Right parentheses and enter, and we get a value of 21. So in other words, if we scroll down, we'll see that we had a value of less than 0.64369 and greater than 0.5, basically 0.56. If I scroll back up and go to the Formulas tab and recalculate the worksheet, then we get 23, recalculate again, 31. That's an unusually high value. One more time, 19, which is only slightly below average. So as you can see, every time we recalculate the worksheet, we get a new arrival time based on the Poisson distribution with a mean of 20. Now that we have the structure in place to calculate each customer's arrival time, with the first starting at time 1, we can add the code to create new customers when the ticker, the simulation's internal clock, reaches that arrival time. In this movie, I'll add the customer generation code inside the ticker loop and calculate the arrival time for the next customer as well. My sample file is chapter 0403, and you can find it in the chapter 4 folder of the exercise files collection. In this workbook, on the sim setup worksheet, you'll see that we have the station data over on the left and the Poisson data for arrival times on the right. You might see a different value in cell K2, which is currently the active cell, and that's just because we're using randomization to create new values. So don't worry if what you see is different. We won't be making any changes on this worksheet in this movie, so I'll press Alt F11 to move to the Visual Basic Editor. In the main code module, I need to go down to the start of the ticker loop and add code to create customers. So I will scroll down and I'll take a look. There we go. I have for L ticker equals 1 to L total ticks. And I have check if a customer is due to be created on this tick. If not, do nothing. So I'll click below those comments, which I added for documentation, and I can start adding my code. First, I will create the top line of an if-then statement. So I'll do if L ticker equals L create next at then, and press return twice and press tab. Now note that I have initialized L create next at above as 1. So that means the first customer will be created as 1. I've also defined the customer ID counter as 1. So the first customer's customer ID will in fact be 1. And also above that, you see the total number of ticks in the simulation. And I note in the comment that each tick represents 10 seconds in an 8-hour day. So we have 2,880 10-second increments in 8 hours. With those variables in mind, we can go back to the if-then statement. First thing we need to do is create a new customer object. So that will be set, because it's an object variable, obj customer equals new, and our class is ccustomer. So there we go. We need to add that customer to the customers collection, which we've defined elsewhere. So customers.add space obj customer and enter. And now we need to initialize the values for the customer's properties. So I'll have customers and L cust ID cntr, the customer ID counter, which I initialized to 1 earlier. Close parentheses, period. The property is cust ID or customer ID equals L cust ID cntr. There's the first property. And now I will copy the identifier for which customer we're working with, as well as the period, and press Ctrl V to paste it. The next property is start time. That is equal to 1. Ctrl V again, and it's next station equals 1. So everyone is always going to start at station 1 in the simulation. Ctrl V is idle equals 1. So the customer starts out idle and is waiting to move to a station. Ctrl V again. Idle time equals 0. So they haven't been idle yet, even if they enter the system and their status is set to idle. We'll increment that value later. Enter, and then the final property. So I'll press Ctrl V, entered. This is the time that a customer entered the simulation, equals the time on the ticker, so L ticker. Press enter twice. Now we need to recalculate the active sheet, and you can see above that I have activated the sim setup worksheet, so I can read data from it. And that will be active sheet.calculate, and enter. And now we can use the value that we just recalculated in cell K2 to indicate when the next customer will arrive. So when we create the next customer. So that will be L create next at equals L create next at, in other words, the current value, plus, and then the value from K2, which is in the active worksheet. So active sheet.range, left parentheses, double quotes, K2, close the quotes and parentheses, period, value. There we go. And the final thing to do is to increment the customer ID counter. So press enter twice, LCUST ID CNTR equals, same variable, +1. Everything looks good, so I will press backspace to move to the left, so I'm on the same level as the if, type end if, and we're done. The code we just created will determine when the next customer should be created and initializes values, as you see here, in the code that we added within